it's only slightly less charismatic than I promise I don't unfortunately have any videos or pictures of anything cute or cuddly in my presentation here. But I'm going to talk about relationships between hydrology and aquatic fauna, meaning fish, crayfish, small freshwater shrimp, here in the preserve. And these are data collected over the course of a 6-year study that wrapped up last year. In terms of worldwide literature on wetlands, freshwater forests and wetlands are understudied, notably understudied compared to graminoid wetlands. Locally, our understanding of spatial and temporal variation in Big Cypress aquatic fauna community also lags significantly behind that of most other Everglades regions or habitats. And who really cares about fish and forests? I guess would be the obvious question, and the answer is these guys do. Wavy birds that are feeding in cypress forests in this Big Cypress region, and other higher trophic levels that are feeding on those fish. So we set out, starting in about 2005, to do a study with two main goals. The first is to establish a methodology for collecting fish in forests, because it's not something that we know anything about. Most of the Everglades research has been done, throughout the Ridge Slough complex, right up to the edge of the cypress forest, where data collection pretty much stops because of the logistics and the difficulty in trying to collect fish in a forested habitat because of the habitat structure, just because it's a very different animal, so to speak, than the graminoid marshes. So the first thing we had to do was literally start at square one and come up with a methodology, a sampling design that would work in this system. And I'm not going to talk about that part of the study today. Our conclusion was that this 1 meter squared throat trap was the best method to use to really quantify aquatic fauna standing stock. And conveniently, it's also the methodology that's used throughout the rest of the greater Everglades, so our data would be easily compared with other data collected in the system. So our second main goal was to collect baseline data on aquatic fauna communities that could be used to detect and understand changes from SERP projects. So really looking at the role of hydrology in shaping aquatic fauna communities within the preserve. Our studies focused primarily in 3 sentinel sites in the preserve, one up in the Bear Island area, one up in the L28 addition lands near the Interceptor Canal, and one at Rafting Point. We sampled 5 times a year, throughout the 5 times each hydrologic year, that basically spanned from the early wet season to the late dry season. Again, the study was conducted for 6 years, beginning in the 2005 wet season, so that's water year 06, into the end of the 2011 water year. And we used a stratified sampling design, basically because of the local scale habitat variation and therefore hydrologic variation. We basically took the cypress domes, kind of sliced them up into almost hydroperiod categories. We sampled in the wet prairie, here outside the dome, the shallower part of the dome, which is like an intermediate hydroperiod forest, and the long hydroperiod forest, which is right next to the deep water refuge at the center of the cypress dome. So at each site, we had 3 replicate plots. Within each plot, we stratified the sampling, so we really encompassed all the variation on that scale. So these are monthly rainfall averages throughout the course of these 6 years. The thing I want to point out here is just the different patterns that we saw. The bars representing what we refer to as typical rainfall patterns, wet season, a dry season. In 2008, we had a significant dry season recession event. We got, I want to say it was only 4 or 5 inches of rain here in February that really raised the water levels throughout the preserve. And they slowly did come back down. They did come back down that year. And then water year 10, we just had a lot of kind of rain throughout the dry season. So it was an uncharacteristically wet dry season. And looking at how water levels responded to that, I know the colors probably don't show up well. The thing I want to point out here, though, is that you see the same pattern pretty much in all the years. These are water levels at one of our sites just from 1992 to present. So it's kind of looking at a pretty big time chunk. The dashed line on the top here is the maximum water level on each day. This lighter line on the bottom is the minimum, and the black solid line through the middle is the average of those years. The thing I want to point out is that they're mostly following the same pattern as the water level rises, begins to fall into the dry season. In water year 08, when we had the rainfall in February, you can see how much that really spiked up the water levels in the swamp. And they did finally again slowly come back down. In water year 10, which is this blue line, that's when we got rain throughout the dry season. And you can see those water levels go up and kind of stay up through the end of the dry season. So that really gave us, within our 6 years of data, 3 different kind of what I call hydrologic scenarios. One is the gradual recession, so that's kind of this normal, drying throughout the dry season. Reversal year, water year 08, when we got that rain in February, and then the no recession year, which is what I refer to it as. And water year 10, when we just had consistent rain throughout the dry season. So I'm going to look at each of these 3 scenarios and look at explain how the fish and crayfish community responded to that. This is an NMDS, so these are community data from our site. If you're not familiar with this type of graph, basically each dot represents one of our 3 sites during each of our 5 sampling events during those years. These are community data, so basically it's just showing that the closer the 2 points are together, the more similar the communities are, the farther they are apart, the more different the communities are. And what's interesting here is you can see a gradual transition. This is early wet season, mid-wet season. This is the transition from wet to dry season, mid-dry season, late dry season. So throughout the hydrologic year, you see this gradual shift in the community structure. And just to kind of put some pictures of fish up here, because I started putting this together and realized I didn't have any fish pictures. This is what those communities consist of. Mosquito fish are everywhere. They're significant players in the community pretty much throughout each season of the year. In the early wet season, so when the waters first come up, when the swamp first re-wets, we see mostly juvenile crayfish and some adult Everglades crayfish and tadpoles. This is really the only time of year that you really see a lot of tadpoles out there in the swamp. As the season progresses, we move into the mid-wet season, so we're talking like October-ish. We see mostly Everglades crayfish and flagfish. Moving into kind of the wet, dry season transition, so around December, we're starting to see the slough crayfish come in. So Everglades crayfish are shorter hydroperiod, a species of crayfish that's associated with shorter hydroperiod areas. The slough crayfish are associated with longer hydroperiod areas. So you see in the wet, dry season transition, you see the crayfish community kind of transition from an Everglades crayfish community to a slough crayfish community. This time of year, you also see a lot of dragonfly larvae, and the grass shrimp begin to become more common. Going into the mid-dry season, so this would be February-ish. You've lost most of your Everglades crayfish. That species burrows underground, so they're usually staying in the shorter hydroperiod areas and going underground. Most of the crayfish you'll find that time of year tend to be slough crayfish. You also still see the dragonfly larvae, grass shrimp, and the least killifish. And then finally, towards the end of the dry season, right before the swamp dries down, again, slough crayfish, you see a lot more grass shrimp, a lot more flagfish, and also the bluefin killifish, which is a fish that's characteristic of longer hydroperiod areas. Throughout the system, they're usually the last fish to show up. They just disperse a lot more slowly. So looking at these communities, I have a couple of these different graphs. Basically, they're just broken down into the bluer the fish, grass shrimp or yellow, crayfish are orange. There's not a lot of tadpoles up there, so I wouldn't worry too much about them. And then this is time throughout the hydrologic year, from the beginning of the wet season to the end of the dry season. And what you see in these gradual recession years, you see an increase overall in the standing stock, the amount of fish and biomass that's out there, but you also see it switching over from mostly kind of a crayfish-dominated system is something that's dominated by fish and shrimp towards the end of the year. And just to show that total fish density, you can see an increase there of fish throughout the year. So you're really seeing the concentration of biomass in the dry season. Here's a picture of what that looks like. This is in the center of the cypress dome in the dry season. If we zoom in here, you can see these are mostly all yellow bullheads, mosquito fish, and they're at the surface because the dissolved oxygen levels are so low there in the water that they're trying to get to whatever oxygen is in the water, in some cases gulping air from the surface. All right, looking at the years when we saw the 1 year in our study that we saw the dry season reversal, it's interesting. We started to see the community shift in the same way we saw the other years, from the early wet season to the mid-wet season. This is the transition season here, so this is December. When the water came back up in February and we had that reversal event, the community actually shifted more back towards what it was earlier in the year. So not only did the water come up and kind of set the hydrologic clock back, but it also kind of set the fish community clock back a little bit as well. And again, you can see the density begins to increase as we go into the dry season, and then the water comes up because there's more water, the same amount of fish. It kind of, well, literally waters down the population, and the overall density is lower. You also see, because that happens, that the crayfish don't go anywhere. They're staying around in the system. So in the previous slide, I showed you this graph where the crayfish pretty much left, and it was all fish and grass shrimp. We didn't really see that during this reversal year. And here's again looking at the total fish density. It begins to rise, and then when the water level goes back down, you see that fish density drop off as well. And then finally, in water year 10, we had a lot of rain throughout the dry season. So we basically ended up with, and the swamps never dried down, so we basically ended up with a 2-year period where we didn't have a dry down. And so that's what I'm showing here. This is the community at the beginning of that 2-year period. This is the community at the end of that 2-year period. You do see a shift from the community from the beginning to end, pretty much the same directional pattern that we saw before, but the variation in the middle of the year is not distinct. So the community, there's not the same apparent shift that we saw in the other years. And in terms of fauna concentration, again, the first year we didn't have a dry down. We never see a concentration of fish. We never see the crayfish go away. They stay in the system pretty much the whole time here. Going into the second year here, as the water levels finally do begin to fall again, we do see the same switch over from a crayfish system to a fish and shrimp system that we saw in more typical years. And we do see the concentration at the end of that second year. It's important to look, I know you can't tell in this graph, but the densities that we saw at the end of this 2-year period were pretty much the same as the density we saw at the end of the 1-year period. So it looks like the duration of inundation really isn't limiting that maximum fish density. So just to conclude here, the clear shift from a crayfish-dominated community to a fish-dominated community was demonstrated here. And we saw that variation in rainfall patterns can definitely have a dramatic impact on prey density, and thus the availability of prey for wading birds. And the best case scenario for them, obviously, is that gradual dry season recession. And this sensitivity that we were able to document of the system to variation in hydrology is very important in light of any proposed restoration activities. Any rewetting or changing alteration of the hydrology in the Big Cypress, in my opinion, would have a significant impact on those fish densities, which of course is then very important to the wading birds that are feeding on them. So after getting this kind of initial understanding of what was happening at those 3 sites, and really that was kind of one of the first quantitative baseline descriptions of what a fish community in these cypress forests looks like. We then set out to increase our network of sites up in the Northeast Addition lands. This is the part of part of the preserve that would be most affected by any restoration activities coming from the L28 interceptor or the West Feeder Canal. That's the area of the preserve, if you've been up there, that has cypress domes that are very choked out. And I don't know as much about what it was like historically, but it's a very, very different cypress dome system than in other parts of the preserve. And so we spent about 2 years scouting out sites up there, setting up sites, and establishing this network. The green sites are sites that were established. This is our initial sentinel site up in that region. And then we also kind of set up a network, and we're never actually successful in working with the tribe to set up sites up there. But the initial design was to have this network where when these SERP projects went into effect, we could track any variation in these communities coming down from these two directions, from the two primary canals that were to be adapted with SERP. And then in October of last year, the lights got turned off. The budget cuts with the district completely canned our project, and our data collection stopped. So the 6 years of data that we have is really all that we know about the system, and really all that anyone knows specifically about the aquatic fauna community here in the Big Cypress. And I know Dale's going to talk after the break here about some of the bigger implications with the SERP project and fish monitoring throughout the Great Everglades, but just not specifically here in the preserve. And I do want to point out here how different the preserve is from other parts of the Everglades, from this ridge and slough complex. Seems kind of intuitive. Of course, we have a cypress forest, and that's a ridge and slough landscape. It's all the same species of fish. They're moving around in the same way. The water goes down, the fish, very predictably, you'll get the same species of fish moving at the same time, using the same cues as you would in the Greater Everglades. But the topography is very different. The Big Cypress system is much more compartmentalized than the Everglades National Park, than the ridge and slough system. Because of this compartmentalization and this habitat mosaic, longer distance dispersal of fishes is probably not as easy, if possible, in some cases in the preserve. So even though we have the same animals moving in the same predictable ways, some of these landscape scale differences, and even some of the local scale differences between the Big Cypress system and the kind of Greater Everglades system may make our knowledge of Everglades aquatic prey dynamics not able to apply directly into the Big Cypress. There may be ways to interpret it in different ways. The work that we've done these last 6 years may help kind of bridge that gap, but we're definitely not looking at apples and apples between these two systems. And that's all I've got. I want to thank our funding for these 6 years was funded by Recover, which is the co-op of the Army Corps. This is help for Water Management District. Big Cypress staff have been tremendously helpful to us throughout our time here, and we've gotten a lot of great advice and help from other folks that